We're all pretty used to AI that can answer our questions, right? But what if an AI could actually build an app for you from scratch? We are right on the edge of this huge shift, moving from AI that just gives us information to AI that actually takes action. And to make that happen, well, they need to go to the gym.
Okay, so here's our game plan. We're going to start with the big vision, then get into the major roadblock that's holding everything back. After that, we'll step inside the AI gym that researchers built to solve this problem, look at the actual results from the training, and then talk about what this new future of AI learning really means for all of us.
So, first up, let's talk about the end game. What is the ultimate goal that's pushing all this incredible research forward?
The dream, really, is to build what we call agentic AIs. Now, agentic is just a fancy way of saying they have the agency to act. So forget just a simple chatbot. Imagine an AI that can build an entire piece of software. Writing the code, testing it for bugs, and then fixing those bugs all by itself. That's the destination.
And that's what an Agentic LLM is at its core. It's an AI that's not just sitting there waiting for a prompt. No, it's actively out there in a digital environment, using tools, trying things out, messing up, and, this is the key part, learning from its mistakes to get a job done.
But, as you can probably guess, building these super capable agents is not easy. There's a really fundamental flaw in how we've been training AIs up to this point, and it's been holding us back.
The problem is something called the single-turn trap. See, most AI training is like a pop quiz. You ask one question, you get one answer. Simple. But the real world, it's all multi-turn. Think about debugging a piece of code. It's not one step. It's a whole sequence of actions, checking the results, getting feedback, and adjusting your plan. That's the kind of complex back-and-forth thinking we need to teach these AIs.
And the researchers who wrote the paper put it perfectly. They said that training an AI on these simple, single-turn tasks is like trying to train an athlete by just making them read the rulebook. They never actually get on the field to play the game and learn from real experience.
So, to break out of that trap, researchers knew they needed a totally new kind of training ground, a place where AIs could finally, play the game. And that is where our AI gym comes into the picture.
Meet GEM. It stands for General Experience Maker. And it is exactly what it sounds like. A state-of-the-art gym, but for AI agents. It's a simulated world where these AIs can practice, run drills on complex tasks, and basically get stronger through hands-on experience.
And honestly, the gym analogy just works so well. The diverse environments in GEM, those are like all the different workout machines and playing fields. You've got coding challenges, logic puzzles, you name it. The integrated tools, that's the specialized equipment, like a powerful calculator or a search engine. And the standardized interface, well, that just means every AI plays by the same rules, so we can actually track their progress and see who's getting stronger.
Of course, having a really fancy gym is one thing, but it's totally useless if the athletes aren't actually improving. So the researchers put GEM through its paces to see if this new way of training really works.
To really test this, they started with a simple but really clever problem. How do you teach an AI not just to get the right answer, but to get it in the smartest, most efficient way possible? So the task they used was a classic guess the number game. Super simple. The AI has to guess a number between 1 and 50, and after every guess, the only feedback it gets is higher or lower. The real challenge here isn't just finding the number, it's finding it in the absolute fewest steps possible.
Now, here's the kicker. There's a mathematically perfect strategy for this game. It's called a binary search. You basically always guess the number right in the middle of the remaining options, which cuts the possibilities in half every single time. And if you do that, on average, it takes about 5.6 guesses to win.
And this is where it gets so cool. The researchers created an incentive for the AI to be fast. Basically, for every extra guess it took, the reward it got was a little bit smaller. They never explicitly taught the AI the binary search strategy, but through trial and error, it figured out that this was the best way to play to get the biggest reward. It learned the perfect strategy all on its own.
Okay, so next up, they tested what happens when they give these AI agents access to those powerful tools we were talking about earlier, the specialized equipment in the gym.
And the results for complex math problems were, well, they were pretty amazing. An AI trained with this reinforcement learning scored around a 41 on its own. But when it was given a Python tool to use as a calculator during its training, its score rocketed up to almost 50. That's a massive improvement, just from having the right piece of equipment.
And we see the exact same story with question-answering tasks.
An AI without any tools scores about a 24. Give it access to a search tool, the score almost doubles to 45.5. This just proves it's not only about raw intelligence, it's about teaching the AI how to effectively use the right tools for the job.
Oh, and for the more technical folks out there, the study also pinpointed a really effective training algorithm. It's basically a refined version of a classic method, and it proved to be an incredibly strong and flexible foundation for teaching these AIs how to handle these really complex, multi-step challenges.
So you can see, GEM is so much more than just a single piece of software. It's really a blueprint for a whole new way of thinking about and developing AI, one that's built from the ground up around learning from experience. And the path forward from here is pretty clear. Standardize, compare, and then accelerate. By creating a standard training environment like GEM, researchers all over the world can finally compare their methods on a level playing field. And that, in turn, is going to massively speed up our progress towards building these truly capable autonomous AI systems.
All right, let's bring this all home. What's the big picture here? Why should we really care about a gym for AI?
So, why does all this matter? Well, because we are watching AI evolve from just giving single answers to taking multi-step actions. And to do that, it has to learn from experience, not just from reading static data. GEM provides that standardized arena for this whole new era of training to happen. And the result? More efficient, more powerful AI that can actually use tools to solve real-world problems. And that leaves us with a pretty incredible question to think about. For years, AI has learned by basically reading the entire sum of human knowledge. What's going to happen when it starts learning from its own experience too? What kind of new frontiers are we going to unlock when our most powerful tools start to learn in the very same way that we do?